All right, thanks everyone. And thanks out to our break sponsors, GoDaddy, NTT, and IIX Peering. Coming up next, we have Tom Coffeen with Infoblox. He's going to talk about DHCPv6 and bring your own device. Thanks, Tom.
Thanks, Greg. Hello. I'm Tom Coffeen with Infoblox. If you're not familiar with Infoblox, we're focused on DNS, DHCP, and IP address management mostly, which has been turned into an acronym as DDI. So if you hear that acronym and you don't know what that is until now, then hopefully now you do. So being a DDI-focused vendor, we end up interacting a lot with enterprise networks. The biggest part of our customer base are enterprise networks. And my own role in the company is an IPv6 evangelist, and a lot of what I do is try to get enterprise networks and IT administrators and CIOs to think about what they're going to need to do to adopt IPv6. And so there's a lot of explaining and cajoling and browbeating and whatever I can do to try to get them to think about the task that's in front of them. Because as you might imagine, most enterprise networks are pretty much safely ensconced behind NAT using private address space in the v4 realm, and so they're not, in many cases, really all that concerned about what they're going to need to do internally on their networks to adopt IPv6. So as part of that role, and we would try to get them to set aside thinking about doing dopey things like deploying NAT66 and ULA internally to the network if they're not really thinking about what that might mean down the road. But part of the role is also figuring out what we need to do on the product side to make sure that whatever features that we have in IPv4, that there's some roadmap to supporting them in IPv6, because I think there's a recognition that v4, v6 feature parity is a necessary, if not sufficient, condition for IPv6 adoption for both enterprise and service provider networks. So in my presentation today, I'm going to talk about one feature in particular, DHCP fingerprinting, and the goal of really making sure that we future-proof that feature with DHCPv6. And the whole reason that we need a DHCP fingerprinting solution in the first place, which has everything to do with BYOD. And so with that, I'll go to the first slide here. So the agenda today, I'm going to talk about what BYOD is. If you haven't heard of it, you've been living under a rock or working for a service provider, you have no idea what that is. We'll go into DHCP fingerprinting. We'll talk about how it works in IPv4. And we're going to take a look at the fingerprinting data that we need to actually have DHCP fingerprinting do what it's supposed to do. And then we'll talk about the possible benefits of fingerprinting in both DHCP v4 and v6 land, and the differences in how v6 DHCP fingerprinting works, and then finally the potential value of building an open database for DHCP v6 fingerprints. So really the goal with DHCP fingerprinting, just to sort of state it in a nutshell before we start out, is to really provide some basic level of device type and OS detection at the level of the DHCP transaction. And as we'll see, this isn't really designed to be a hardcore security feature on corporate and enterprise networks, but really rather a way of just providing a basic level of initial validation. And we'll see how we're going to be able to act on the data that DHCP fingerprinting gives us about the device to make some policy choices about how we want to deal with that device on a corporate network. So here's a little fun quiz. I'm fond of answer C, line 4 on the eye chart. Your mileage may vary with that one. But of course, as I've already sort of given away, if you haven't heard of it before, BYOD, an abbreviation for bring your own device, end user personal devices on the corporate network. So most of us, I think, have heard of that before today. So the general challenge, again, just to sort of restate it, accommodating the new flood of personal devices that are being brought into the corporate enterprise network environment. Getting these devices connected to the network and supporting them once they're connected but making sure that the devices aren't a security risk, being able to identify the device type and the operating system that they're running, recognizing that some device types and operating systems are potentially subject to being infected with malware more frequently than others, granting them access according to the security requirements that you have on the corporate network, and then tracking the number and type of devices that you have connected over time as a way of refining a BYOD policy so that you actually know what's connecting to the network and you've got some ability to shape your policy accordingly as far as what devices you're going to allow to connect and what devices you aren't. So we'll see that DHCP fingerprinting by itself isn't really going to solve all of the BYOD challenges with the flood of personal devices being brought into the corporate network environment, but it's an important sort of foundational technology. So along the lines of why the BYOD challenge is coming to an enterprise near you, this is a graph from a Mary Meeker presentation, Kleiner Perkins, talking about the explosion of mobile devices that we're actually seeing being purchased in the marketplace. And so you see this tremendous growth in unit shipments of iPad, iPhone, and iPod. So, and as we'll, this crowd is probably more aware than most in our field of the need to support these devices with addresses, recognizing that we're rapidly approaching IPv4 rundown. It's already happened in Europe and Asia, of course, and North America's next. So right at the moment that we see this incredible explosive growth in personal devices that we're going to need to provide addressing for, we're also simultaneously running out of the address resources to give them addresses. So here's another graph showing pretty much the same thing. Something approaching exponential growth in the sale of Android and iPhone shipments. Cisco, there's a lot of numbers floating around out there as far as the sort of the saturation of mobile devices, the overall penetration per capita. Initially, Cisco was predicting something like 7 billion devices, or global per capita mobile device saturation by 2015. Well, apparently that's going to happen this year. So we're already at the point where we have 7 billion mobile devices that we need addresses for. But here's a slide that sort of really drives home the explosive growth of mobile devices over the last several years. This is an event that took place, I'll give you a hint. If anybody recognizes it, feel free to shout the answer out, but this is an event that took place in Europe back in 2005. Does anybody know what we're looking at here? Do we have any, I'm sorry? That's right, yeah, I was going to say, do we have any Catholics in the audience? Or any lapsed Catholics, perhaps? This is the inauguration of Pope Benedict back in 2005, and you can see in the lower right-hand corner the lonely flip phone with its camera application. And of course, you know where this is headed. Flash forward to 2013. It's probably too far for those in the back to see, but if you look closely on that iPad in the front there, you can see the iPope app being run. And the rumor is that Grand Theft Auto Vatican City will be out in time for Christmas. But really, a remarkable slide for just showing the explosion of mobile devices that are out there. And of course, driving home the point that we just simply don't have the address resources to support all the mobile devices that are coming online. And no NANOG presentation would be complete that touched on IPv6 without the obligatory Dr. Jeff Houston slide showing IPv4 rundown. And I haven't updated this in the last couple weeks, so I'm not sure where we're at now, but pretty clearly we've got an inference here that if we're going to try to deal with the BYOD challenge in the corporate network environment, the devices that we're talking about that are coming online are going to need IPv6 addresses in the first place out there in the wild, woolly world outside of corporate networks. So with that, let's talk a little bit about what DHCP fingerprinting is and how it works. We're going to see that this is one of the methods to help manage the flood of personal devices entering the workplace and needing to connect to the network. DHCP and DHCPv6 fingerprinting have promise as a sort of foundational method for managing devices at the most basic level, making sure that we know what they are and that they're running a proper OS before we actually give them an IP address and allow them onto the network. So the original idea was around creating a basic validation mechanism. And I wouldn't say a security mechanism, that's probably too strong of a word, because there's all sorts of ways in which you could flummox this system if you're really of a mind to do it. And of course, in a corporate network environment, there's some presumption of other layers of security that you're providing, so that we're not really looking for DHCP fingerprinting to be a beginning and an ending for security for devices that are connecting to the network. But here we have the goal to determine the client type using only data from a basic DHCP transaction. So here's the generic LAN segment with the host and DHCP client, as well as DHCP server. We've got our discover packet. The basic method of the fingerprinting technique is simple. Any client wishing to connect to a corporate network, in nearly all cases, as long as DHCP is involved, they have to request an address via DHCP. And of course, that means that we're going to see a discover packet on the wire. Generally, that first packet, whether it's a discover packet in IPv4 or, as we'll see later, a solicit packet in DHCPv6, it actually contains sufficient data to do a basic device type identification and OS type identification of the device. So let's dig into the packets and see what's going on under the hood, and I'll blow this up a little bit here. The basic DHCP transaction has a number of option fields, and these are consistently unique enough among individual devices that we can read them in a particular sequence and with the number that are presented in order to reliably characterize the device type, such as whether it's an iPhone 4 or iPhone 5, iPad 2, Samsung Note, etc. And also the device OS, which might be more important in terms of determining whether or not we've got an OS that actually should have the privilege of connecting to the network. So, iOS 7, Fedora 18, Windows 7, Service Pack 1, etc. So for DHCP and IPv4, and we'll blow this up so you can see it a little better, option 55 is the most commonly used field for identifying the device type, and this is our parameter request list. So we'll expand the parameter request list and take a look at some of the parameters that are being offered in the discover packet or the solicit packet in v6. Actually, it's a little bit different in v6, as we'll see later in the presentation. So we've got quite a number of options here, and I don't know, it's maybe kind of hard to see in the back of the room. I don't really, as the DHCP server that's doing the fingerprinting, I'm not really concerned about the options per se, each individual option per se. Of course, I might use those as part of setting up the host with the proper address and DNS resolvers to look at and that sort of thing. But as far as DHCP fingerprinting goes, I'm really only after the list, the number of parameters being requested in the order that they're being presented in. But it's just kind of fun to actually look at the parameters that are here. I don't know if anybody's ever seen this before, and I don't know if you're toward the back of the room, you may not be able to see it, but we've got option 119 here, which is domain search. And it actually says to do RFC 3997. So I can't recall ever being nagged in a packet capture to go bug the IETF DHC working group to update RFC 3997, but there it is in the packet. So again, we're really only concerned here with the number of options that we're being presented with and the order that they're being presented in. And this is our list. Now that we've got our ordered list and unique parameters under option 55 in a DHCP discover from an unknown client, what do we do with it? Well, we're going to need some sort of database to actually make the next step in the DHCP fingerprinting process. And as it turns out, there's at least one publicly maintained source for DHCP fingerprinting. It works in IPv4 because we've got a relative abundance of client fingerprints. And so Fingerbank is maintained by the company Packet Fence, which offers a captive portal solution, but they've also got this public database of IPv4 fingerprints that can be used for DHCP fingerprinting. So if we refer to that database based on our earlier parameters, we see we've got a match That's a closer look. And we see that with that list of options under option 55 in the DHCP Discover packet, we've got a Fedora 17 client. And we can look at the host side of things to verify that that's actually the client in question. And there we have a uname command showing us that that's a Fedora 70 client. So now you're getting suspicious and you're saying, okay, I get BYOD, I get mobile devices being brought in to corporate networks, but what mobile devices are running Fedora 17? And it's a fair question, but here's the answer. The IT administrator's worst nightmare. Properly identified by DHCP fingerprinting or not, I don't think they're going to let you connect this to the corporate network. Yeah. Okay, so really the neat thing going on with DHCP and DHCPv6 fingerprinting is that we get actionable data with no additional transactional overhead, because we've got this DHCP Discover packet that's being sent anytime a client is requesting an address and access to the network, or a solicit packet in the case of v6. We've got enough information included in that packet to reliably identify the device and the OS type. So once we have that information and we know what the device is, we can allow or disallow or conditionally allow network access. We can hand it off to a captive portal type solution, but we don't even have to do that. If our DHCP server is savvy enough, we can basically do the basic permit or deny of that device to connect to the network upon request of an address. We can generate reports to learn what devices are connecting over time, what OSs they're running. And as a result, your BYOD policy as an IT network administrator, you can really sort of refine it over time to make sure that it makes sense based on the devices that people are actually bringing in. The nice thing too is that there's no additional load on the DHCP server unless you've got some reporting functionality that you're really running quite heavily. Then it's not really going to show up as additional transactional overhead on the DHCP server. Of course, you have to have a DHCP server that's slick enough to actually handle the fingerprinting. But again, rather than hammering the device with Nmap, host OS detection, and driving up the utilization on the device, you can do this all with the transactional data that's built into the DHCP transaction. So we tested this out at Infoblox headquarters, and we had folks just bring in whatever they wanted from home that could actually connect up to the network in v4 land. And we got quite a number of devices, as you might imagine. We were able to identify all sorts of devices based on the fingerprints that are in the database. Nintendo GameCube is actually something somebody brought in, and maybe if you're an administrator, you're okay with folks having that connected up to the network, maybe not, but you have a basic method for detecting it using this DHCP fingerprinting process. We identified over 78 unique devices, and we could identify the operating system in about 81% of the cases. So pretty good, not great. Again, not an end-to-end security solution, not something that is going to replace your existing security regime on a corporate network, but nice to have. And here's a sample of some of the OS data that we saw, devices and OSs. So now we'll look at how this works in DHCPv6 because it's slightly different. And there's an issue with DHCPv6 that will prevent it from being actually being a feature that we can use in the same way that we're able to use DHCPv4 fingerprinting today. So there's our generic LAN segment again with the DHCPv6 client, DHCPv6 server, and again, same goal, identify the OS and the type of device that's connecting. Of course, we've got a different set of protocols that are allowing us to do this. We've got a multicast packet this time around, DHCPv6 solicit. And as you can see, you've got the link local source address and the all DHCPv6 server's destination address, so that's obviously a big change. And that's in multicast instead of broadcast, of course. And the presumption here, it's pretty much presumed that enterprise networks are not going to be using Slack unless it's a lab environment. You want tight control over the hosts that are connecting to the network, and you just don't have that sort of visibility and functionality in Slack. So, the whole reason that DHCPv6 fingerprinting needs to be considered in the first place, we're presuming that we're going to continue to use DHCP in the corporate network environment as we adopt IPv6 internally. So there's our packet capture again, but this time around we don't have that option 55. We've got some critical options which we'll take a closer look at, but the key difference is where we had option 55 in IPv4 DHCP, in DHCPv6 we have this option request option 6. But unfortunately we have typically fewer options that appear under option 6 in a DHCPv6 solicit. And so we may have to fall back to using some of the other elements that are being presented in that solicit packet to figure out what the device type and OS is. And that can include the vendor class field where it's present. We can look at the timing of how often the clients are sending a solicit message. There's also the client identifier field in DHCPv6 solicit packets that could be used. In this case, we're actually going to have enough data. We've got, here's our list of client parameters that are showing up in the packet. The options in order are message type, client identifier, option request, and requested option codes for DNS recursive name server and domain search list, as well as the elapsed time and an identity association for a non-temporary address. So, and you can see here that the client identifier option gives us the link layer address, which may be of use depending on how we're actually going to do that DHCPv6 fingerprinting on the backside with the DHCP server. So many fewer options, but we're still able to map that back to Fedora 17. But of course, the fingerprint is only accounted for in an existing DHCPv6 fingerprint database, and that's where we're running into an issue here, that we've got somewhere around 200 fingerprints currently in the Fingerbank database, and I haven't checked this in a while, so that number may actually be more at this point. But right now there aren't any for DHCPv6, and of course this is likely due to the chicken and egg problem that we've run into in many areas with IPv6, where we've got a lack of general IPv6 deployment in environments where fingerprinting is potentially most useful, that is the enterprise and corporate networks. And so we don't really see the BYOD challenge impacting corporate networks that are allowing devices, mobile devices to be brought online because they're really not running IPv6 yet. But that doesn't mean they're not going to. And of course, we need to be in a position where we've provided that feature parity between IPv4 and IPv6 to lower the friction for enterprises to do the right thing and adopt IPv6 in the sanest way possible and get the most benefit out of it. So Infoblox is collaborating with the University of New Hampshire Interoperability Lab on a public DHCPv6 fingerprint database. And again here, the benefits, as I've talked about, the feature parity, which will be durably useful over time as more enterprises turn up IPv6 internally. And of course, it increases the likelihood that the greatest number of devices will be accurately identified over time. It may encourage the deployment of DHCPv6, which we certainly want to do, and it may encourage effective BYOD policy. But the main thing for me is that I hope that it'll encourage enterprises to feel like they've got another tool in their belt to help effectively manage IPv6 and adopt it internally, rather than putting it off and just assuming that, just like what they're doing now with IPv4 and running NAT, private address space, that they can possibly get away with the same thing in IPv6 land and do an ugly thing like put NAT66 at the edge and run ULAs inside. So that's about all I had today, and I look forward to any questions you might have. And thanks for your attention.
Any questions?
I know it's boring enterprise stuff, but
Over here, maybe.
I'm Andrew Sullivan, and I work for Dyn. It wasn't clear to me from what you just said. Is the same database being maintained for v4 DHCP stuff?
So there's already a database that Fingerbank is running, and I don't know, right now, because that seems to be something that's being updated on a fairly regular basis and seems to have good data. Of course, this is one of the issues, right? I mean, we need to have some way of validating the data and making sure that that it's reliable. There's a trade-off, because obviously we're not trying to make DHCP fingerprinting this incredibly powerful security tool. It's basic validation, but you still need some sense that the database has the correct information. So I think over time that'll be worked out where, there'll be a canonical source. The goal is to keep it open so that, we can sort of crowdsource it and make sure that we're getting the most number of devices accounted for. The challenge there, of course, is that, somebody could introduce junk into the database and then scuttle the effectiveness of DHCP and DHCPv6 fingerprinting.
Right, so you actually presaged the real question that I had, because I was wondering what the, how accurate the updates have been over time in the other. The reason I'm inspired to this is that over in DNS land, of course, we used to have this nice, fingerprint device, and it's useless now because it's all.
Yeah, that's
wrong.
right.
So it would be really interesting for somebody, but I'm not volunteering, to sort of check the history of the V4 one to see how good it's been over time, because that would give us some evidence about what it's going to be like for V6.
I think that's absolutely right, and I think what we'll see over time is that initially there'll be it'll be a collaborative sort of crowdsourced effort and more open, and then of course it'll become more proprietary as more organizations start to actually rely on that data, and that's not necessarily a bad thing, but initially, I think it's better to have it open and really help drive adoption of IPv6 in any channel that we can, and it might be one of those things that allows us to do that. So, but good question.
Anton Capella, 5 excellent presentation.
Hey, thanks.
I was waiting for this one since we saw it come out of the PC tool.
Okay, great.
I'm curious about whether or not you've looked at yet, or if there's any, obviously just don't do that, it's bad, it's worthless research or information you have regarding maybe timescale aspects to the clients. So for example, everything you talked about here is just whatever you can see passively, which is perfectly sensible here. Another thing that seems like it could be a passive correlate is the order by which DHCP4, V6 are emitted, and perhaps how quickly it responds. Maybe the OS is doing something after it gets the first response to the Discover packets and so forth. So I'm curious if you looked at anything in that space yet.
Yeah, we're just now digging into it, and I think we will get that granular with it over time. The bigger challenge that we're seeing right now is, and this is probably no surprise to folks here, but a very inconsistent behavior of DHCPv6 clients, right? So, where it literally changes from code revision to code revision in terms of how DHCPv6 solicits are being issued, and we're just, frankly, some devices just aren't, providing useful information. They're not actually generating DHCPv6 solicits based on the fact that they're not properly supporting v6, even though they claim that they are. So I think over time, as we see more, sincere development of devices, mobile devices that support IPv6, and they get really serious about, writing the proper code for supporting IPv6, and that filters down to what's happening at the DHCPv6 layer. I'm hopeful that will allow us then to look at more granular aspects of what's going on and more accurately identify the device types. But when you have DHCPv6 clients that are sort of all over the map in terms of their either whether or not they work at all or whether or not they work reliably, then that's sort of a larger issue, at least initially. And so hopefully with this process, it shines a little bit of light on that and maybe puts a little more pressure on the mobile device manufacturers to code DHCPv6 a little better. So,
thank you.
Sure, thank you.
Matthew Moylecroft, not at Amazon. To put a provider spin on this, would this be useful for identifying CPE out on a cable network or something like that? So you could identify, especially when they have firmware issues and things like that.
Yeah, that's a great inference, and absolutely. I mean, to the extent that you're willing to deploy DHCPv6 in that environment, then there absolutely isn't any reason why this wouldn't work. And again, give you some basic level of device and type validation, and I could see that would be extremely useful where you have an environment where folks can buy their own CPE and connect it up, and then perhaps you can have a policy that's on the back end that your DHCP server is actually exporting the important data that allows you then to script things and provision accordingly based on the device that's being connected. So, it just depends on how labor intensive you want to get with it.
I was actually thinking also, if you see a new CPE behind a cable modem, then at least if someone calls in and goes, "Hey, I've got a problem, it doesn't work anymore," you go, "Hey, you've got a new router."
Yeah, exactly. Yeah, yeah, that's very good. Just basic, and that's really in the spirit of what fingerprinting is for, is basic validation. And in that case, obviously, you can really improve your operational offering to the customer. So yeah, good point. Yes.
David Barak, AT&T Consulting. Is there any concern about either false identification or masquerading?
Yeah, I think so. Yeah, I mean, that's clearly a risk here. And again, you have to kind of take the feature for what it is and not try to make it do more than that. And we really see it as sort of low-hanging fruit in an enterprise environment where chances are you've already got, you may already have a mobile device management system running. You might already be using NAC of some sort. This is just another layer of device identification, validation, not necessarily security. But because we're talking about an enterprise network environment, again, access to the wire, the other layers of security that are there, if you've got a problem with somebody infiltrating the building and connecting things up that shouldn't be there, so there's that sort of trade-off where the security risks are offset, I think, by the fact that you're in a much more lockdown environment in the first place. And but you should be clear-eyed about, everyone should be clear-eyed about what the feature is and isn't, and it's never going to be designed to be a heavy-duty security feature. And there's always that risk that you could certainly do some spoofing or potentially gain access to the network by gaming the DHCP server with a fingerprint that you say your device is one type and it's actually something else, for instance.
I'm sorry, we're going to have to cut off questions as we run over at this point. Sorry about that. Tom will, I'm sure, be glad to take more questions outside.
Yeah, absolutely.
All right, thanks a lot, Tom.
All right, thank you.